Okay, so hopefully you've had a look at the previous video which allowed us to manipulate between RFM, concentration in moles per decimeter cubed, and concentration in grams per decimeter cubed. So if you have a look at that and you were able to manipulate between these three equations that I have on the board now and do some of those problems, and you've checked those and you're getting those correct, it's time to move on then to actually taking those problems and putting them into an actual equation and being able to deal with more of an exam style problems. So the questions in the previous one might be worth a few marks at sort of equation, but the ones we're going to do now will be worth a few more than that. Okay. So if you are one of my students from school, you will have task number 5. Okay. If not, and I'll blow it up there. I'll work through 2 or 3 of these kind of once you've got the idea, and then whenever it comes to the end, what I'll do is I will put the answers up. You can cut back to this part of the video and have a look at the questions, and you can do a few of them, pause the video, do a few of them, and then check your answers. Okay, so I'll do sort of a moderately easy one, and then I'll do sort of a middle one and maybe a slightly more challenging one. There's not a big pile of difference between all of them. There is more videos on this topic in titrations, which kind of takes up the reins from where I leave off here. Okay, so you might want to, if you finish this and you want to do some more challenging work, head over to those videos on titration calculations and do those. Right. Okay, so we're going to take number 1 here, and the question is, so we're asked what mass of magnesium reacts with 100 cubic centimeters of 2 molar hydrochloric acid. Okay, so the first thing we've got to do is make sure that we've got our equation written out and we've got our equation balanced. So I've given you the equation and I've given it to you balanced here. So the next thing I would do is, just whenever you are working out or doing your working out on a piece of paper, guys, in school, okay, or at home, wherever, okay, just take that equation and fill in the information that the examiner has given you. Make sure you don't make any transcription errors. So the examiner said what mass of magnesium will react with 100 cubic centimeters of 2.0 moles per decimeter cubed hydrochloric acid. And then I always do put a little question mark under, just to remind me what is it that the examiner is actually asking us for here. Okay, well, so in order to get grams here, which is of course mass, I need moles and I need RFM. Well, RFM and magnesium we just get from the periodic table, group 2, it's 24 grams. Of course I need moles. I can't get moles unless I've got mass, but I can get moles indirectly by using the ratio. So just very quickly, remind yourself of the ratio here. So 1 mole of magnesium requires 2 moles of hydrochloric acid. So if I have 2 moles of hydrochloric acid, I need 1 mole of magnesium to react fully with it. So can I get moles of hydrochloric acid? Well, of course I can. I've got moles up here is equal to concentration in moles per decimeter cubed times volume. Remember, that's in decimeters cubed. Okay, so my concentration is 2. My volume in decimeters cubed is 100 cubic centimeters divided by 1000 is 0.1. So my moles of hydrochloric acid is of course equal to 0.2 moles. I take that across and I use a ratio. The ratio is 2 to 1. So 0.1 goes to, 0.2 is simply divided by 2, gives me 0.1 moles of the magnesium would be required. Now I can get to mass, because I've got mass equals moles. I've now got it. Got the RFM earlier, so it's that. So I would need 2.4 grams of magnesium to react fully with 100 cubic centimeters of 2 mole per dm cubed hydrochloric acid. Okay, hopefully that makes sense. So we're really introducing now into some ratios, right? So this time, if we go and we'll have a look at number 4. So number 4 is slightly different. Okay, so on number 4, excuse me, on number 4, we have been asked this time to calculate out a volume. So we'll just write out again. So if we look at the question number 4, it is this time what volume of 2.0 moles per dm cubed copper sulfate solution reacts with half a gram of zinc. So let's again write out our equation. So that's zinc plus our copper sulfate solution gives us zinc sulfate plus copper. Okay, so again we write in the information the examiner gives us just to remind us of it. So it's 2.0 moles per decimeter cubed copper sulfate solution. We have half a gram of zinc, and again a little question mark beside what they're after, so we know what we need to get. So it is a question mark on the volume, so we're after volume, and in order to get volume I need concentration. I've got it. Well, I need moles also. I don't have moles, okay, but I can get moles indirectly from my zinc. Remember, it's 1:1 ratio, zinc to copper sulfate. So can I get moles of zinc to allow me to then use the ratio to get moles of copper sulfate? Well, I've got mass of zinc, and mass equals moles divided by the RFM, so I just need to find the RFM of zinc, which is 65. Okay, so I do 0.5 divided by 65, so 0.5 divided by 65 gives me moles of 0.00769. If I have that number of moles, if I have 1 mole of zinc, I get 1 mole of copper sulfate to react with it. So if I put that number of moles of zinc, 0.00769, it'll be the same number of moles of copper sulfate. Okay, I'm after volume this time. Volume equals moles, which I just got, divided by the concentration. The concentration given to me in the question, that is 2, gives me 0.00385. And remember, our volume always comes out as decimeter cubed, so if the examiner did ask us to turn it into centimeters cubed, which they may well do, it becomes multiplied by 1,000. Becomes that. Okay, so we'll have we'll have a look at one more. Okay, so we've got again, so we'll look at number 8. We'll just zoom in on it and then we'll zoom back out again if you want to have a note of the question. Okay, so in fact, I'll just use this here for saving you writing it out. So what mass of sodium carbonate? So again, I'll just write question mark grams. It is needed to neutralize 100 cc's of 2 molar sulfuric acid. Okay, so 100 cc's of 2 molar sulfuric acid. Alright, so that's 100 cc's. Now you might want to sort of get into the mode, guys, of being able to convert that into decimeters cubed just very quickly. It's a good skill to have, to be able to divide these numbers in your head quickly by 1,000. Not very difficult, okay? And then we have a concentration of 2 moles per decimeter cubed. Okay, so if we go back to our equations that we had earlier, I need to get mass of this. So for mass I need moles and RFM. I can get the RFM of sodium carbonate, okay, by adding 2 sodiums, 1 carbon and 3 oxygens, so that's 46 plus 12 plus gives me 106. Sorry, 106 is the RFM of that. Alright, but I don't have, and I'm after mass, I don't have moles, but I do have a ratio here to here, and the ratio, as you hopefully worked out, is 1:1. Okay. I can get moles of this, which is simply 0.1 multiplied by 2, 0.2. Okay, I'm just using their concentration, which is given to me in the question of 2, and volume in decimeters cubed, which is 0.1. I use my ratio, it's 1:1, so my moles of my sodium carbonate is 0.2. Mass is equal to moles multiplied by RFM. Moles is 0.2. RFM I've worked out there earlier is 106. Okay, it gives me an answer of 21.2 grams of sodium carbonate required to react with sulfuric acid. Okay, so hopefully those are pretty straightforward for you guys. That's the sheet of questions. I'll zoom in on it there so you can have it, and you can have a go at it if you. I've done a couple couple of them already, of course, but no reason why you can't do the rest, just to check. Okay, I'll leave it up there for a few seconds if you want to pause it, and then I'll put the answers up as well, so at least you know that you're going along the right lines. Okay, so those are the answers. Question 1 at the top there, run all the way through to question number 8, so make sure you can check those off. If you did your answer in decimeters cubed and mine's in cubic centimeters, well then just divide by 1,000, okay, and you should get the same answer. The units are not so important. What is important is that you actually put the units on. So for example, don't write here 22.5 and just leave it blank. Make sure if it is cubic centimeters you write. Better to write, actually I'm being a bit slack there, better to write cm cubed. Okay, likewise for masses, if a question comes in kilograms, you may generally give your answer in kilograms, but if you do happen to give it in grams, please write the G at the end of it. Don't just leave it as a number. Sometimes the units are given in the answer, so you don't have to write them down, but just be careful that if they're not, that you put the right units on. Okay, hopefully that's of some use. As I said, there are other videos on titrations and more complicated ones, more challenging questions. Alright.